This video is going to go over question 8 from your test. It says that the daily new cases of COVID-19 in New York City reached the peak value on April 14th, and then the daily new cases began to fall. The natural log value of new cases on April 21st and April 28th are 8.7 and 8.3. So part A is asking us to express the natural log value of daily cases as a linear function of days post-peak. The first thing I want to think about is how many days post-peak April 21st and April 28th are. So since our peak day is April 14th, let's call this day 0. Well, April 21st is 7 days after April 14th, so let's call this day 7. And similarly, April 28th is 14 days after April 14th, so that would be day 14. Okay, so we have 2 points that we get. On day 7, our log value of new cases is 8.7. And on day 14, our log value is 8.3. So now I have 2 points. To find the function, a linear function, we need the slope and we need a y-intercept. So with my 2 points, I can find my slope by subtracting the difference between my y's and dividing it by the difference between my x's. So we would get 8.3 minus 8.7 over 14 minus 7. And when we type that into our calculator, we're going to get negative 0.057 approximately, and that's going to round to negative 0.06. So that's my slope. This is my m. My linear equation model is y is equal to mx plus b. So let's plug in the m that we just found. We would get y is equal to negative 0.06 x plus b. So now to solve for b, I can either plug in my first data point or my second data point for y and x and then solve for b. I am going to choose to plug in my second one. You could just as well easily choose the first one. I'm just choosing to do the second. So my y is 8.3, negative 0.06 times my x, that's 14, plus b. Okay, let's simplify the right-hand side a little bit by multiplying. So negative 0.06 times 14 in my calculator, that tells me negative 0.84 plus b. And now we can add 0.84 to both sides. So that gives me 9.14 is equal to b. So my linear equation would be y is equal to, my m we knew is 0.06 x plus 9.14. 9.14 is my b. So here's my linear equation. Part b is asking, what are the value of the slope and the y-intercept of this linear function? What do they represent? Well, my slope, we just found, is negative 0.06. And so what that represents is the rate of decrease in the natural log value of new COVID-19 cases in New York City. That's what we found when we subtracted the COVID-19 cases over the number of days that occurred. My y-intercept is 9.14. And what that tells us is on day 0, which was April 14th, that's the log value of new cases, 9.14. So what that tells us is that the y-intercept represents the natural log value of new COVID-19 cases during the peak. So during April 14th, that's my log value of new cases. Okay, moving on to part C, we're going to work on over here. So it says, it is known that the actual value of new cases decayed exponentially after the peak. Use the above slope and y-intercept to derive the exponential model for new cases in the form n of t is equal to n naught times e to the negative kt. Cool. So let's write that down. N of t is equal to n naught e to negative kt. Let's start by taking the natural log of both sides. And what that's going to allow us to do is get that in terms of some of our data points that we were using, since that's the natural log value of daily cases. So we would take the natural log of n of t and the natural log of n naught times e to negative kt. Well, the natural log of n of t, that was our y value in our equation y equals mx plus b. So we can call that y of t. On my right side, my natural log of n naught times e to the negative kt, I'm going to use the product rule to separate that. So we'd have the natural log of n naught plus the natural log of e to the negative kt. Simplifying even more, we get the natural log of n naught plus, well, ln of e to the negative kt, that's just negative kt. Wow, so now we have something that looks like a lot like a linear equation. We have our y is equal to ln of n naught, that's just some number, minus kt, our t is time. Okay, so this is actually our y-intercept, and this k is our slope. So our y-intercept we remembered from before, that was 9.14, and our slope is negative 0.06. So we know that the natural log of n naught is equal to 9.14. So n naught, this is equal to approximately 9,321, and my k is equal to 0.06 because we have a negative k. So it's positive 0.06. Cool, so now we have our values that we can plug in into our model. So we get n of t is equal to our n naught, where we found that that's 9,321 times e to the negative k, so negative 0.06 t. Let's see. Part D is asking us to use the exponential model to predict the new COVID-19 cases in New York City on May 14th. Well, we know May 14th is 30 days after April 14th, so this would be n of 30. So that's equal to 9,321 e to the negative 0.06 times 30. And when we plug that into our calculator, that's approximately 1541 new cases.